So our first thing to chat about is just how to look at our quantitative versus quantitative data, which would be with a scatter plot. Typically, we're on the lookout for a linear relationship because that's all we're going to tackle in our class. But if something is nonlinear, there are methods to actually handle that data. We just won't be covering them in this class. So here we have an example of a scatter plot. A scatter plot takes ordered pairs. So this person over here, they're very tall. They have a height of 79, it looks like, and a left arm length of 28. I have no idea what the measurement units are for this. They should put that on this axis, but they didn't. So each of these ordered pairs represents one person, their height, and their arm measurement. So if we look at this scatter plot, I want you to take a moment and just determine what you see. Not what I tell you you can see, but what you see. So hopefully we're noticing as the height increases, so does the left arm length. This has what we would call a positive trend, right? Because if we fit a line to this data, which is where we're headed eventually, the line would have a positive slope. As one increases, so does the other. Taller people tend to have longer arms. We could also say, like I said, if we want to eventually fit a linear trend, this does look like it follows a linear trend. But we might notice that there are some unusual observations, right? Right? And I'm calling them unusual because they're far away from the trend of our data, not necessarily far away from the average like we were thinking before. This person has very average height, but when you look at their height, left arm combined, they're really far off of this trend around this line that we have, right? In fact, they are very tall and have very short arms. This is a T-Rex person, right? And when you talk about outliers, unusual peeps, when we're, I'm sorry, statistical term, unusual people or unusual observations in a scatter plot, you do want to say where they are. So this looks like someone is about 74, 23. And I think this one looks pretty far off the trend as well. They're kind of out there in no man's land. And that's at about, looks like 62, 26. So in this case, this person is very short, that has very long arms. They're more monkey-like, which I would make fun of, except for we did an activity during an department meeting one time, and I was like the only person whose wingspan was longer than their height. So apparently I might fall into that situation. So that's a scatter plot. That's some of the things that you can interpret, and I haven't even gone through the next page, which is like the actual interpretation. We could also create a scatter plot. This is not something I would ever have you do by hand, but it is nice to do once just so you can get a feel for what the heck the scatter plot's telling us. So in this particular exercise, we're looking at how many times a cricket chirps versus the outside temperature. So making these by hand is a little bit silly because in real life, you would just use technology, and technology would do all of this work for us. So the first thing you have to decide, and this is true whether using technology or doing this by hand, is which should be on our x-axis and which should be on our y-axis. Which of these seems like our explanatory variable, and which of these seems like our response variable? Which of these seems like our independent versus our dependent variable? Remember all those different definitions we had in part 1? So we kind of want to think of it this way. What influences the other one? Which makes more sense? Is it that the chirps influence the temperature, or that the temperature influences the number of chirps? Hopefully we immediately see the only one that makes sense here is temperature influencing chirps, because it's not like they're making enough friction to change the temperature around these little crickets. So we're dealing with our x, I'm going to erase this stuff just so I have more space, is temp, which might influence how much crickets chirp. That's not how you spell chirp. If you ever watched The Big Bang Theory, there was like an episode where is that how you spell chirp? No, God. It's like crip, but wrong. There was an episode where there was a cricket that they like captured, and we're trying to figure out based on how often it chirped what type of cricket it was. Anyways, so now that we figured out which is our X and which is our Y, we're going to go ahead and make our axes and label them. Will be better than that previous one where I have no idea what the measurement unit was. And I'll spell chirps correctly. And now we can decide what our axes should start and stop at. So we want to look for the min and max of each of these. So temperature, our minimum temperature looks like it's 47 and the maximum is 89. So I'm going to start this off at 40, 50, 60. Yeah, you guys don't need to hear me say it. 90. All right. And then for chirps, same deal. Looks like our lowest number of chirps is 6. Highest is 50. Oh, why do I keep doing this? So we will do 0 up to 50. 10. Okay, I believe that we can figure out what the rest of those numbers are, even though they kind of got in the way of Maxie's label. And we're literally just going to take some time to put all of these points on the graph. That's it. So I'm going to pause it, and then we'll come back, and your graph will look just like mine, and you will know exactly what a scatterplot's all about. So your graph will look something like this. I do want to mention one more thing that we could have talked about if we look at both of our graphs at once, the one with the arm length versus height and our temperature versus chirps. Which of these seems like a stronger relationship? Because again, we could use most of the same descriptions here. As temperature increases, so do chirps. So it also has a positive relationship. Also looks like it follows a linear trend. But I don't really see any unusual observations. So we would say that this is a stronger relationship. And now we have a preview of everything that's coming on the next page. Sorry, my handwriting is terrible. It's very small. It's hard to write on.